This is the spec for the module on the distance formula. Distance formula. And it's really just to make sure students know how to find the different distance between 2 points, and hopefully get an intuition so that they realize that it's really just the Pythagorean theorem in disguise. So the question we'll ask them is find the distance between the points, and we could color code it here. So the first point, maybe it is 3, 4, and maybe the other point is -2, -6. So we want to graph those 2 points. So -2, 1, 2, 3, 4, 5, 6 is right there. We could label it -2, -6. And then the other point, 3, 4, is 1, 2, 3, 1, 2, 3, 4, right over there. And we'd, of course, want to label it. So if the student doesn't know how to do it, all these choices are going to be potential distances. And we could do the incorrect choices to be things that you would get if you incorrectly apply the distance formula or incorrectly manipulate it. So the first hint that we will give students if they don't know how to do it, we can say that the change in x, let me do it in the black color, change in x is equal to, and we could just subtract, always the smaller one from the larger one, but it doesn't matter which direction we go in. But we could say 3 minus -2. So we'd say 3 minus -2, 3 minus -2, which is equal to 5. And then we can show it on this graph here. We could show that this right here is of length 5. And if they click hint again, we will say change in y is equal to 4 minus -6. 4 minus -6, which is equal to, we'll do another color, 10 right here. And we can actually display it right here, change in y. We could show that that distance right there is 10. And then we could say the distance, and then if they click hint again, and let me find a suitable color that I haven't used yet. So if they click hint again, the distance is just the length of the hypotenuse of the triangle, the right triangle displayed. And we can just, in that same color, draw the hypotenuse right there. So we could draw it in a color that makes it clear. And then if the student clicks hint again, by the Pythagorean theorem, that length is equal to the square root of 5 squared plus 10 squared which is equal to the square root of 125. And let's see, if we want to simplify that at all, let's see, 125 is 5 times, well, we have a 25 in there. So this is equal to the square root of 25 times the square root of 5, which is equal to 5 square roots of, this is 5 square roots of 5. And we could write it into the next line. You don't have to write it all right under this thing like that. It'd probably be easier to implement, so it's right here. So 5 square roots of 5. And we could even label it in that same color, 5 square roots of 5. And so the choices would be a bunch of things like, maybe 5 square roots of 5 would be here. Maybe if a student doesn't know how to I don't know, take this square root properly. Maybe we could put 5 here. Maybe we could put, I don't know, we could do something naive where it's just, I don't know, 9, where it's just if you subtracted things some bizarre way. Maybe we could put something like the square root of 3 over 2. Just things that would confuse the students a bit. Y'all could think of other ways that you might misapply the distance formula. Put a 1 here. You want a couple of radicals and a couple of numbers without radicals. And that's it. You just keep giving the students different points here, and then they just give them the steps to apply the distance formula. We might also want to mention that, look, the distance formula, we just derived the distance formula. But I think this is a better way. That way you'll never forget it, that it's really just the Pythagorean theorem.